Here are the solutions to Geometry Mastery Check 25234, version A. We have to first complete this proof. So we have our statements and our reasons, our 2-column proof. And here's the information we have. Given E is the midpoint of DF, we have to prove that DE equals 23. So DE is this distance between these 2 points. And the first thing in our proof says that E is the midpoint of DF, and that is exactly what was given. So our reason for that is that it was given. Number 2, they're asking us for a statement that we can tell because of the definition of a midpoint. And that statement would be that segment DE is congruent to segment EF. You could also write this length DE. So the no line on top means length, and when we're talking about length, we just use a regular equal sign, EF. And then, so that's saying that, because E is a midpoint, DE is equal to EF. And next, now that we know that, we can say that 6x is equal to 8x minus 1. Or sorry, 6x plus 5 is equal to 8x minus 1. And all we did there is we took this algebraic value of DE and we substituted it into our equation that we had in step 2. And the same for the algebraic value of EF. So this is the substitution property of equality. And if you were wondering what those POEs meant, they mean property of equality. And we do a lot of things just to shorten how much we have to write, because these 2-column proofs can be a lot of writing. For number 4, the next thing is our equation somehow went from 6x plus 5 equals 8x minus 1 to 5 equals 2x minus 1. And what they did there is they subtracted 6x on both sides. So that is the subtraction property of equality. And we went over all of these in our lesson on, was it Monday or Tuesday? Monday. We went over these algebraic properties of equality. And there's something that you should have written down so that you can remember when you're writing your proofs, you can say, I have to use an algebraic property of equality. And if you look at a list, it's going to be a lot easier for you to pick the right one. All right, the next thing, we need to use the addition property of equality, because what we're going to do is we're going to add 1 to both sides. So 5 plus 1 is 6, and 2x minus 1 plus 1, well, the minus 1 plus 1 cancels out, and it's just 2x. And they want us to use the division property of equality, because algebraically the next thing we would do here is divide by 2 on both sides, and that would give us 3 equals x. Now they're going to use the fact that DE is equal to 6x plus 5, and that was given to us. It was given to us in the picture. So just because it doesn't have the word given before it doesn't mean you can't use given as your reason. If it's in the picture, there's always some words and the picture that goes with these. If it's in the picture, you can use given as your reason. And then we know that x equals 3, so we can substitute 3 for x, and that's the substitution property of equality. And then finally, we can say that DE equals 23. And that is simply done by evaluating. I'll just write evaluation here. Now, if you wrote, like if you just wrote substitution, subtraction, and you forgot the POE, or if you wrote substitution, property, or if you forgot that and you tried to explain it in your own words and you did a pretty good job, those would all be things you would get credit for. It's not going to be super picky that you have exactly what I wrote here, but you should have these ideas. And I think the way that I wrote it is the easiest. It's about as short and concise as you can do. When people end up explaining these things in their own words, you might end up writing a lot here. And if you did that, congratulations, you've took your first step on understanding how proofs work and why they work the way they work, and why knowing something like substitution property of equality is valuable. Proofs are tricky at first. They get easier with practice. So if you're watching this, if you had a mistake on here, I would highly recommend retaking this, especially early on, because we're going to be doing proofs throughout the quarter. And the sooner you get comfortable with them, the happier you'll be for the rest of the quarter. Okay, let's look at the next questions. So now we're using which lines or segments are parallel, justify your answer. So we have to have some reasons for our answers. In section 3.3, we went over several properties or theorems that will be useful. So make sure you've looked carefully through section 3.3 and written down those theorems. This first one, well, we have a pair of angles here, and if I'm looking at these lines and evaluating whether they are parallel, I can say they are because these arcs in the corners, I'll highlight them blue here. All right, that's not what it, all right. These arcs are congruent, and they are alternate exterior angles. So I can say that Q is parallel to S by, alternate, and I'll abbreviate. Again, we do a lot because we want to minimize the amount of writing. Alternate interior angles. Alt-int angles. If you were wondering if T and R were parallel, well, we can't tell. They sure look like they are, but we don't know anything about any of these angles over here, so we can't make any statements about the angle pairs between the intersections on line T and the intersections on line R, so we cannot say if they are parallel or not. Same with number 11 here. We can't say anything about line segment BC because we don't know anything about those angles. We do know some angles over here on line segment AD, so we may be able to prove that line AB is parallel to line DC, and indeed we can. So line AB is parallel to line DC. And my reason, I'm just going to say by, and now what I have here is these two pair, and they're in alternate interior angles, which is another way to show that these lines are parallel. So we're going to say by Oh, shoot. I made a mistake on this one. Sorry. I wrote interior when I was supposed to write exterior. These angles are on the outside of the parallel lines. So they are exterior. Exterior means outside. These angles are inside. This is the interior of the parallel lines. So we can say if alternate interior angles are congruent, then the lines are parallel. So my reason is by alternate interior angles. All right, for number 12, we're going to find the value of x for which r is parallel to s. If r is parallel to s, then we know that I'll mark these angles, all the corresponding angles are congruent, and the non-corresponding angles, or these, so I've marked, okay, so let's put it this way. All the green angles, and I should put 2 arcs for the other set, because that's the way to show they are different, but the blue ones are also congruent. So all the green angles are congruent, all the blue angles are congruent, and any green-blue pair will add up to 180. They will be supplementary. So 98 and 3x minus 17 are a green-blue pair. So that means that 98 plus 3x minus 17 has to equal 180. There's no multiplication or anything going on here, so these parentheses don't matter. So 98 plus 3x minus 17 equals 180. I can combine the 17 and the 98. Negative 17 plus 98 would be 81. Equals 18. And now I'll use subtraction. This is the subtraction property of equality. If I subtract the same thing from both sides, the equation will remain true. I see I'm almost at the bottom here, so I'm going to shrink. Oh, that shrunk everything. There, I gave myself some more room. Okay, so I get 3x equals 18 take away 81. I'm going to check that in my calculator. You don't get any bonus points for doing these things in your head, and sometimes you make mistakes. 18 take away 81 is negative 63. Whoops, something crazy happened. How did my 180 become an 18? I was going through and checking my answer, and getting a negative number for x really doesn't make any sense. So I knew I made a mistake, and then I looked, and something happened to my zeros there. So 180 minus 81, that's 99. So 3x equals 99, divide by 3, and we find out that x must equal 33. I'm going to check that really quick. So it must be that 98 plus 3 times 33 minus 17 equals 180. So I'll put that in my calculator. 98 plus 3 times 33 minus 17 equals 180. And if it does, then I'm correct. And it does, so I can rest assured that I got that one right. Always check your answers. You should be able to tell whether you are correct or not. All right, if you have any other questions, feel free to email us. Otherwise, the retakes are available. So good luck on those. And we'll see you in the next live lesson, depending on when you're watching that. That might be Monday at 11 or Thursday at 11. It's on your Google Calendar. Have a great day.